All right, we're going to do the same thing with this example. It's the same example, same function in the first video, but now we're going to talk about the breaking points, because I want you to try and visualize the fact that this graph is in 3 pieces, right? We're going to have 3 different looks to our graphs as we go across the domain and as we go across this x-axis. So since we have 3 different looks, different parts of the graph, we're going to have 2, what I like to call breaking points. You won't really see that term anywhere. That's just what I call them. So we have 2 breaking points, and you can easily see them in how you write piecewise functions. We have a breaking point at -2, right? Because this domain stops here, and it starts with the second one. And we have a breaking point at 3. So we have breaking points at x is equal to -2. And we have another breaking point at x is equal to 3. All right, and what you want to do here is you want to evaluate, this is going to sound a little strange, but you want to evaluate them at both ends of the break. Now we know for right here at this first break that this is not equal to -2, okay? So when we evaluate -2 here, we're going to write that under the not equal part. So you can see for each breaking point, you're going to have an output that's not equal to it and an output that's equal to it, right? Same thing for 3. We have an output that's equal to 3 and an output that's not equal to 3. And when we graph it on the next round, that's going to make sense because we're going to see those open and closed circles. We're going to see an open circle at the break where it's not equal to -2. We're going to see a closed circle here, and then an open circle. So try and hang with me through it since we don't have the visual yet. So we're going to evaluate the function at x is equal to -2 for when it's not equal to -2. Okay, so that would be here at x plus 1. All right, so for x plus 1, when I plug -2 in for that, -2 plus 1 is just going to give me -1. So the point where it's not equal to is I have it -2, -1. Okay, and I'm just going to put this symbol here. This is going to be an open circle when we graph it. And again, I'm going to write this down on another board I have that we're going to use late in the next video. Okay, now we're going to evaluate -2 where it is equal to x, okay, and that's for the 5, okay? So it's constant really at that part 5, so we know that it's just equal to 5. So my output there is at -2, 5. And that's going to be a closed circle when we graph it. All right, now let's try the other breaking point and see if you can follow me a little bit better now that we have one under our belt. So we're going to graph where the breaking point is equal to 3. Excuse me, we're going to evaluate it where it's equal to 3. Okay, so it's equal to 3 in the second piece, which is 5. Again, there's nowhere to plug it in, so we know it's just equal to 5. So we have an output at 3, 5. And again, it's going to be a closed circle, right? When it's equal to something, closed circle. Equal, closed circle. Not equal, open circle. And then we want to evaluate 3 where it's not equal to 3. So 3 where it's not equal is this third piece at x squared. So when I evaluate 3 at that function, it's 3 squared, which is 9. So my output there would be 3, 9, and it would be an open circle. Okay, so what we did here, just to recap, we evaluated the breaking points, and we evaluated it where they're not equal to it and where they're equal to it. And we're going to see why we need to do that when we graph it. And same thing for number 3. So if you have 2 breaking points, you should have 4 outputs for that breaking point, and each breaking point should have an open circle and a closed circle value. All right, in the next video, we're going to graph this. All right, now let's graph this function. Now, like I've been saying, this goes along with the first 2 videos we did, and I have written down the points that we have acquired from each video. So let me show those to you real quick. We've got video 1 and video 2. All right, so in video 1, we came up with these 3 points when we evaluated the function at random values. And in video 2, we evaluated the breaking points. So we came up with an open circle and a closed circle for -2, and we came up with same thing, an open circle here and a closed circle for +3. And hopefully when we get this on the graph here, it's going to make sense. So maybe I'll put that right here, and you should be able to see that in the screen. And I will plot each of these points. So I'm going to plot the blue ones here. Notice here that my graph, so we can fit everything, the x-axis is by 1s and the y-axis is by 2s. So I've got 4, 1, 2, 3, 4, 16. It's going to be up here. Right, because 2, 4, 6, 8, 10, 12, 14, 16. Then I'm going to graph the second point at 0, 5. Okay, so that's going to be right in between 4 and 6 here. And I have -5, 1, 2, 3, 4, 5, and then -4. Again, going by 2s on that y-axis, right? So -2, -4. All right, so those 3 points. Now, we don't want to draw anything yet, because remember, this is not a line, okay? This is a function that has 3 pieces, okay? So now we need the breaking points, okay? You're going to, hopefully it'll all come together here. So we've got -2, 1, 2, and then -1 is an open circle. And I've got -2, 5 as a closed circle. All right, so this is a breaking point, right? We're going to see in this first piece, it's going to stop here, and then it's going to jump up here and start. Okay, so we need a ending and a beginning point. All right, and then I'll graph 3's breaking point. I've got 3 and then 5 here. All right, that last video ended with me plotting the point 3, 5, and 3, 5 is a solid circle, okay, that we found in our breaking point video. And then I already had this graphed, my video cut off, so I'm just summarizing here. So my last point to graph was 3, 9, so there's an open circle here. All right, and then what I did was you would see these random 6 points here in line that you need to connect. And you connect it based on the domains here. So we have the domain of x less than or equal to 2. So here's -2, and so it's going to go this way, right, and go through this point. So this part of the graph represents x plus 1. And then we have to connect the dots between -2 and 3, which would have been these 3 points right here, and that represents this constant function of 5. And then from x greater than 3, we have this open circle up through this point, which represents x squared. So the main thing I want you to see from this graph is the connection between the pieces and what the graph looks like, right? So this first piece is x plus 1, right? Well, we know from our last unit this is a linear function with a positive slope, right? So it makes sense that this piece is a line. We also know from the previous unit that this is a constant function of 5, right? It's a horizontal line, right? It would be the same as y is equal to 5, right? A horizontal line right there. The last piece is a little different because we haven't seen anything squared yet, but we know that it's going to be a little bit curved here based on how close the points are together. And so you need to recognize that each piece has a different look depending on the type of form it is. And then the second thing I want you to make a connection is the domain and the inequalities. So when the inequality is not equal to, notice we start with an open circle. And then when the inequality is equal to, we have closed circles. And then when the inequality is not equal to, we end with an open circle. So right when you look at a piecewise function, you should be able to list off the breaking points of open circle or closed circle, right? So we have open, closed, closed, open. And for any piecewise function, we should be able to do that. So we know where the graph, the previous piece is ending and where the next piece is beginning. And we're going to do one more piecewise function that is not in your notes online, just so we can practice these, tie both of these videos together, all these videos together.